So in last class, we had discussed about program scope, function scope, and block scope. And we had discussed that function scope is inside the function. So what is the scope of main function? It starts with this bracket and it ends when this main function ends. Yes. So any variable that is declared inside this main function will have lifetime and scope up to this main function only. So that is the function scope. And if I am declaring any global variable like this int a is equal to 10, it is above main, it is a global variable. So its lifetime is the whole program. Its scope is whole program. Yes, it can be used inside until whole program is getting executed. Then I have this check function, and if I have any variable inside this check function, so it will also have scope until this check function only. It is not having scope inside main or outside this any global area. Yes. So after that, we had discussed about the syntax of storage class. That first we have to write the name of storage class, the name of the data type, and then the identifier or the variable name. Best example is like auto int a. Int is the data type, a is the variable name or the identifier, and auto is the storage class. It is automatic storage class. So for automatic storage class, we write keyword auto. Okay. And what does this storage class represent? They represent where the variable will get its memory allocation, whether it will be stored in RAM, register, or where it will be stored. And then it represents that what default value will be given by that particular variable or that particular storage class. So automatic and register variables, they give us the default, their default value is garbage value, and static variable as well as external or the global variable, they have 0 as the default value. It also represents the scope and lifetime of the variable, that where the variable will be used, whether it will be used inside the block or inside the function only, or it has scope as the whole program. So this table is very important to represent, and it represents all the storage classes with their default values, where they are, the memory is allocated to them, and what is their scope and lifetime. So when we talk about auto variable, so automatic storage class, so that is stored in RAM. It has garbage value as default value, and its scope is local wherever it is defined, like in main function. If it is defined in main function, so its scope is only inside the main function, so that is local. Yes, means locally inside the function, and lifetime is it can be used only within that function. Extern is the keyword that is being used for global variables. So you can use this extern inside main also. Even then, it will, that variable which has storage class as extern will be considered as a global variable only, and its memory allocation is done in RAM. Its default value is 0, and its scope is global. Means globally this variable can be used. The storage class can be used. That is why its lifetime is till the end of the main program, and this type of variable or the storage class can be declared anywhere in the program. Yes, mainly it is declared above, just above the main function. We have static storage class. It is also memory is allocated inside the RAM only, and its default value is also 0. But its scope is local, means the function where it is being used, and its scope is its lifetime. See now, there the scope is local, but its how its lifetime is till the end of the main program. Yes, so this is like contradictory to the external variable. So you can see that its scope is local inside the function. However, it can also be used outside it. Why? Because the lifetime for this variable is till the end of the main program, and it retains its particular value whenever it is called between multiple functions. Then also it retains its value. Then we have last storage class as register class, and we put a register keyword for the storage class, and memory allocated for this kind of variable of this kind of storage class, it will be the storage registers. Yes, so that is why the programs that are being that are using these kind of variables, they are more efficient, they are actually faster than other ones. So this takes the garbage value as the default value, and its scope is local, and it is same as automatic, like its lifetime is also within the function. Then we can start with automatic storage class. You know that it's in from the previous table only, we know all these things. So like we have discussed this example, that int a is equal to 10, int main, auto int a, then you are printing this value. So for this particular block, now this is an independent block, and there you are declaring a variable independently, auto int a. Yes, so by default, anyways, if you are writing only int a also, that is by default automatic. For automatic storage class, we have to write auto. And for this particular printf, uh, a will be a will have the default value as the garbage value. Yes, so that garbage value get printed. And for the second printf, what we have this a will be now referred to this particular int a is equal to 10. So here a is 10 will be printed. Yes, and this is a global variable that is actually untouched and is not referred anywhere right now in this example. Yes, so this is having garbage value, and second printf is having 10 value. The next is when I'm having this int a is equal to 10, then I think it is the same example. Oh, yes. So if I'm having int a is equal to 10, so this int a is by default a global variable when it is outside the main function. So it cannot be, you cannot write auto storage class here. Yes, so this will give an error. Okay. Okay, so next is that I have these two functions, call1 and call2, and inside this main function, these one of this function is being called. I have this auto int v is equal to 10, then I'm calling this call2 function, and then I'm printing the value of v. Okay, so let us first go through the call2. So when we are going to the function call2, I have auto int v is equal to 3. So I have a variable v, sorry, 30. It is having value as 30. Call1 is being called now. So see, in this example, we have three variables as v. One is having 10 value, another is having 2, or one is having 30 value. So so we already know that auto variables, auto storage class has lifetime only within that particular function. Yes. Okay. So this thing we will use in this program. Then first, when this function is called, then printf v is equal to 20 will get printed, because this is now referring to this v. Yes, and when it comes back this call v2, call to function, then v is equal to 30 will get printed. Yes, because this will now refer to v is equal to 30. Here this auto int v variable. So now control now goes to printf in the main function. So here it is written printf v is 10. Yes, so v is 20, v is equal to 30, and v is equal to 10 will get printed. Okay. Then we have external storage class. So this external variable is visible to all the programs, and it can be used if two or more files are sharing same variable or function. So sometimes it happens that we are using two different programs, and we are talking and we are actually um, sharing the data between those two programs. We have to write extern variable, extern keyword out, before that variable, and you know that the memory it takes is RAM, and default value is 0. Yes, so if I have this int a is equal to 10, this is the global variable, okay, or this is the external variable. And if I write here auto int a is equal to 10, auto int a, so this is now block scope. You know that it will, this printf, first printf will give the value, what it will give? It will give garbage value. And next printf will give 10 value. So now this int a is equal to 10 is not having any meaning. It is the last example only that we had already discussed. Yes. So you know this example. Now if I write here, see, int a is equal to 4, this is a global variable, and int main. Now in this main, I am not declaring any variable. Yes. So if I am not declaring any variable here, so it will pick this global variable as its variable. Yes. So if it is written a is equal to 4, so a into 3, 4 into 3 will be now assigned to a. And a is 4 into 3 is 12. So a is 12 will get printed. Again, print f. A is, now you're calling a function fun. So now in function fun, you have not declared any variable also. Yes. So it will, which variable will be now used? This global variable will be used, again used for the function. Yes. So return a into a. So 4 is the value for that a variable, and for 4 into 4 will be now returned. So a is 16, a is 12, and a is 16 is returned. Yes. Okay, so there is another example. See, now we can start with this main. Yes, so I have this variable extern int a. So if you write extern before any variable, that means it is a global variable. Yes, so a is equal to a into 3, and then you can write a is, what will be the output? A is जो भी आपने a का initial value रही है. Now listen, what we are doing, hash include v dot c. Now what is this v dot c? So this is actually a file that is only containing a is equal to 4. Okay, sometimes in one program you don't write anything hash include or something, you are only writing int a is equal to 4. So that is, int a is equal to 4 is in the global area. So this variable is the global variable. Yes. So you can name this file as v.c. Okay. So in the next program where you write hash include stdio.h, you can also include this file. Okay. So when you include this file v.c, so automatically this a is equal to 4 is now being used in this program. So even if you are not writing this a is equal to 4 here, but it is including with the help of v.c file. Yes. So that a will be now used here, that will be now multiplied by 3, and then you are calling this function fun, then you are multiplying this variable a into a, and now you are giving this keeping this the result in a. Okay, so what will be the output? You can run this program and you can see the output by yourself. Okay. Okay, then we have a static storage class. The static variable is initialized only once. Yes, so it is initialized only once, and it and exists till the end of the program, and it retains its value between multiple function calls. Yes, this we have seen that we have to use static keyword. It is stored in RAM. This variable is stored in RAM, and it has default value as 0. And like this, I am having a program. Okay. So in main, I have for loop, and I'm not giving for the initialization or for the condition and update statement. I am not giving anything. Then I'm calling this function. So for this loop will be infinite loop. And what happens when this gets executed? This print function will get executed. Yes, this will be called many times. So for this print function, what I have, int static m. Yes. What is the initial value of m? We know that default value for m is, for any static variable, is 0. Yes. So even you can write static before int m, or you can write in between like int static m. It is one and the same thing, right? So in the next step, you are incrementing its value m plus plus. Then you are printing the value of m with the help of printf. So you can write hash include stdio.h also. Yes. If m equals to 3, then exit 1. So this is exit 1 function. So exit function is used to exit from the function. Yes, exit from this block. Okay. So when this function will be called, so initial value will be 0 for m, and again m will now become 1. So it will get printed, and then again exit ho jayega, then again it is called, then again see, now because it is static, and every time this static variable now will have that particular, it will retain that particular value. And now then m is now in the second iteration, it will become 2, and then it will become 3, and then 1 2 and 3 will get printed. Okay, so 1 2 and 3 will get printed. Okay, so what is the difference between then int, normal, automatic, and static? That it will retain its value. Once it is declared int static m, once it is declared, it will retain its value throughout the whole program. Okay, it will not be initialized again and again like automatic variable. Static जो variable होता है, it keeps on retaining its last value. Yes, so this is how this program will work. Okay, so next example is for uh, hash include stdio.h, and this function has static int I, this is the static variable, and int j is equal to 0, this is the local variable. I have I plus plus j plus plus, and then I'm printing the value of I and j. And in main, I'm calling this function and again and again. So the first function call, what will I have when this function is called? Then let us go to this function call, function definition. So we have static int I. Yes, what will be the value of I? We have not declared. So I का default value 0 होता है. So I will be 0 and in j is equal to 0. Okay, so you have done I plus plus and j plus plus. So it is post increment, and now I की value 1 will get printed and j भी 1 will get printed. Okay, then we have again we have, when this function ends, we come to main function. So again there is a function called func. Okay, so now again it will go to the function call. So now I have static int I. See, now this variable, it is now declared only once and it will retain its value. What was its last value? It was 1 here. Yes, so that 1 will be now retained, but j is equal to 0 because it is defined, it's, it is newly defined, it is considered as new definition or new declaration. So j will be 0. Okay, so I plus plus means now I will become 2 and j will become 1. Why? Because 0 plus plus usko kiya to 1. ठीक है, so I will be now 2 and j will be 1. Now for the third function call, what we have, I was 2 and j is now 0. So I will be now I plus plus and j plus plus will be now I will be 3 and now j will be again 1. Yes. So you can see I 1 1 2 2 and 3 1. Okay. So this will be the output. You can run this program on your own and try this by yourself. Int A, static int B. In this program, what we have, printf %d %d, you can see int A will have one garbage value and int B, which is static variable, it will have 0 default value. Okay. So this 1 2 3 is garbage value and 0 is the default value for static variable. Then we have register storage class. For this we have to use register keyword, and it has for this variable memory is allocated in the CPU registers, and its default value is garbage value, and its lifetime and scope is local. And if the register is full, suppose you are not being you're not given that register is full and you cannot store your variable inside that register, so that particular variable will be now treated as automatic variable. Okay, so now if I'm talking about this, actually this works same as automatic, but it will be faster than automatic. Okay, so for checking this, you can compile a program. You can write this kind of program. You can take you can take this variable as register in register storage class, and then you can compile and execute this program, and you can check about the running time, execution time for that, for this particular program. Okay, this is the example where everything is now kept inside one program. So I have this function A, B, and C. These functions are being declared here, and int x is equal to 1 is a global variable. So in int main, what I have, int x is equal to 5. I have this x is equal to 5. This is by default automatic variable. Yes, so it has scope local to only the main function. In printf, I have local x in outer scope of main. Local x in outer scope of main is %d. X की क्या value आएगी इसमें? 5. Okay. So this line will get printed and x की value 5 will get printed. Now what is this? From 17 to 21 line, I have a block here and this x is now new variable that is being declared here. So its value is 7. 7 में मेरे पास में I have printf local x in inner scope of main is यहाँ क्या आएगा 7. Okay, so this line gets printed and x की value यहाँ 7 आएगी. Then I have printf local x in outer scope of main. What is this? Local x in outer scope of main. तो यहाँ अभी क्या है हमारे पास में सेम x is equal to 5 वाला यहाँ पर रेफर होगा. Okay, this x यहाँ 5 print होगा. Then I have function call ABC. So what is this about? So I have the function definition here. I have this function definition of a here. So what is this? X is equal to 5, printf plus x, then printf the value of x. Yes. So what if you're calling this function x is equal to 25, तो उसमें printf में आप क्या आएगा यहाँ पर 25 आ जाएगा. X local x in a is 25 after entering a. Yes. Then plus x, this is p increment, so ये 26 हो जाएगा. 25 plus 25 क्या 26 हो जाएगा. And then it is here you can see local x in a is 26 before exiting. Okay. Now what is in b? b में हमारे पास में एक स्टैटिक वेरिएबल है. स्टैटिक में हमारे पास में क्या होता है, यहाँ आपने वैल्यू अगर नहीं दी होगी तो 0 इट विल बी टेकन एज डिफॉल्ट वैल्यू. नाउ यू हैव असाइंड इट 50. Yes, this is called initialization, that you have done, you have initialized the value. Yes, so printf में हमारे पास में क्या है, we'll be writing local static x is 50 on entering b, plus x क्या करेगा, इसको add 1 कर देगा तो वहां पर 51 आ जाएगा. Local static x is 51 on exiting b. Then in c I have, what is this? In c I have this printf global x is %d on entering c. See, now there is no x variable. आप ऊपर देख सकते, there is no x variable. So which x will be referred to now? This x is equal to 1. This is the global variable in the previous slide. Yes. So this global variable will be now used in this C function call. Okay. Or function definition. So I am writing global x is, what was that? What was the value? X is equal to 1. So now I have this printf global x is 1 on entering C, and x into x. So this is compound statement that we have already studied. So x is equal to x into 10. So 1 into 10. So x is 10 now. So global x is 10 on exiting C. Yes. Again, A is being called. So now same scenario will be done for A. And again, B function is called. So earlier B, sorry. So earlier the x, that is static variable, so its value was 51. So now it will be again, so now it will be printed local static x is 51 on entering b. Now plus x is 52, so local static x is 52 on exiting b. And again this will be now, this will be now executed, this c. Okay, so here you can see that this is being now, this is the answer. So here you can see the static, initially it was 50 51, then 51 52. And for the global variable, again that c, for that c, now that will also retain the last value. Yes, so that was having earlier it was 1, then it was multiplied by 10, so it became 10. Now this, that 10 will be now multiplied by again 10. Yes, and 100 is the answer. So this was the example where all of these storage class specifiers are being used in one program. Thanks for this session.